Hello, hello, hello. Ladies and gentlemen, welcome to Measurements. This is the first video for Unit 6. We're going to be going through, talking about different kinds of measurements, and then in future videos, we'll be using these to do conversions between different kinds of measurements. First and foremost, in this class, we are going to be using the metric system, or the SI system. It is often contrasted with our empirical system, the one we use in America, called empirical after the empire, British Empire, that created it. So if you didn't know, America is one of the only countries in the world that still uses the British system of measurement. And the only answer I can say for why is because I guess we're stubborn. We really don't want to make that switch. So we are still using that old British system. But in science, we generally use the metric system. And that is because we want to make sure that things are lining up properly. Apologies, folks. My computer started making a funky noise. Got me a little creeped out. Okay. Now, so we're going to work through the metric system. I'll mention a couple of things about the empirical system, maybe. I kind of want to keep this video fairly short, so I may skip over that stuff. So, SI system, or more commonly known as the metric system, is the English translation of the name. Okay, so SI, where is it? Good Lord, I should have stayed over here. Okay, SI is from the actual name from those who created it, which is the Système International des Units, which is French for the International System of Units. So we call it SI instead of IS in homage to the fact that it is French, not English. So I'll be using SI system and metric system interchangeably. Something you are going to have to add to this notes page if you have not, if you can't have done it yet. Something you're going to need to add to this note page is that the SI system is base 10. One of the most important things about the metric system is the fact that it is base 10. This is a huge contrast with the empirical or British system. Okay, in the British system, we used, it was designed around convenience. And at the time, that was a really big deal. Okay, so obviously we know a foot and a yard and an inch. Those are the three that are still pretty common today. But they didn't just have those. They also had a cubit, a hand. I think there were others beyond those. Those are the ones, though, that I remember. So an inch was defined as the length of your middle knuckle on your index finger of your dominant hand, which was roughly the same for everybody. Hand was the distance from the bottom to the top when you held your hand like this. A foot was literally the length of your foot. A cubit was the length of your forearm from your elbow to the tips of your fingers. And then a yard was the distance from the tip of your outstretched fingers to the tip of your nose, provided you were looking straight ahead. Okay, and these were really convenient measures because at the time, everybody in England had pretty similar physical dimensions. Most people had the same size foot, the same height. People had very similar dimensions, so everybody could accurately measure this stuff. Now, as time has gone by, we see a lot more international travel now than we used to. And so it's not uncommon for people to move to a different country and have kids with people who are from a completely different country. So we see a much wider range today amongst a population than used to be common. And so now, for you, a cubit might be a foot and a half, but for somebody else, that cubit might be 2 feet. Or maybe closer to 1 foot. There's some wide-ranging variance there. Okay, and so at some point they standardized. We got rid of a lot of those. We don't, like I said, we only really use inch, foot, and yard anymore, and obviously mile. But for the most part, we standardized those so that they were the same across the board. But the numbers are inconvenient. So when they were standardized, the length that was about an inch was about 12 of those in 1 foot. So we said there's 12 inches in 1 foot. And then the distance from your tip of your nose to your outstretched fingers was roughly 3 times the length of a foot. So we said, hey, this is a yard now, and that is exactly 3 feet of the standardized foot. I don't remember where 5,280 feet came from. I think the actual goal when they went to yards was, or when they went to miles, I think it was based on the yard, which is either 1,670 or 1,760 yards in one. I'm second guessing that. Anyway, it's a little less than 2,000 yards in a mile, and then 3 times that is 5,280. So take 5,280 divided by 3. That's how many yards there are in a mile. Anyway, those numbers were inconvenient. We have 12 to 1, 3 to 1, and then almost 2,000 to 1. That's our 4-step scale. And it doesn't make much sense. The metric system, though, is base 10. There are 10 of everything in the next measure of the scale. Or 1,000 when you cut out a lot of the scales that we don't really use. So for example, 1 meter, you go up to 10 meters, that is 1 decameter. Okay, if you have 100 meters, that is another thing that starts with H that I can't remember because I've never used it in my life. And if you have 1,000 meters, or 100 decameters, or 10 of whatever that H thing is, that's a kilometer or a kilometer. Going the other way, 1/10 of a meter is a decimeter. 1/100th of a meter is a centimeter, which we should be pretty familiar with. We use that one a lot. And then 1,000th of a meter is a millimeter. Okay, moving up from kilo, we tend to go in thousands from there because you don't really need anything between. So up from kilo, we have mega, giga, tera, and it goes up quite a bit. I don't remember what the order are after that. Going down from milli, we have micro, nano, and pico. And I don't remember a yotometer. I don't remember if that's a big or a small one, but the scale is applied to pretty much all of these. And we'll do a little bit with length, but we're not going to mess much with the prefixes for most of these others. Though you've probably heard of milliseconds. Now, there are 7 types of measurement or main measurements that the SI system accounts for. Okay, those are length, mass, and time, which are the 3 most important and the ones we are going to be working with the most throughout this class. We have done a little bit with charge, and we're going to do some with temperature. So charge and temperature are also important, but we're not going to work with these nearly as much. And the last 2 are chemical amount. I know it says amount, but it's chemical amount, because all of these are amounts. And then luminosity. Now, chemical amount is chemistry only, and that is called the mole. You should highlight mole or moles here, because that is the unit for chemical amount. You need to know that. Okay, luminosity is measured in candela, and that is a astronomy thing. We don't really use that anywhere other than astrophysics to talk about luminosity. So we're not going to do anything with these 2 other than saying, hey, chemical amount is measured in moles, and luminosity is measured in candela. And that's it. We're not going to do anything more with these. I am going to suggest that you come back up here for these 5 as we go through these notes and write out the actual units. So you've highlighted moles, and you should have highlighted candela. I think I forgot to mention that, but you should have highlighted candela because you need to know those. I want you to come back and put the units for length, mass, time, charge, and temperature as well as we go. Now, that should be the long half of this video. The rest of these notes should go pretty quick. All right, length. Length is measured in meters. So meters is what would go up here. Specifically, when we abbreviate it, we use an M. It has to be a lowercase m. A capital M stands for something else called molarity, which is not something we're going to deal with in this class, but it's a type of concentration. Okay, we measure distance with length. Now, length is not limited. Length is not limited to one dimension. There is a two-dimensional version of length. Actually, there's two two-dimensional versions of length. And then there is a three-dimensional version of length as well. So when we use 2D length, the units are squared. When we use 3D length, the units are cubed. So meters squared, meters cubed. The two-dimensional version of length, or versions of length, are area and surface area. And you should jot those down here. Area and surface area. Okay, 3D version is going to be volume. Okay, where we have length times width for area, or length times width times height for volume. Those are all length measurements. There's no mass or charge or time in those. It's just length. Now we're taking length times length, which is where the squared comes from, but it's still length at the end of the day. It's a length unit. Okay. Next one we're going to talk about is mass. Now mass, the standard SI unit for mass is kilograms, not grams. So kilograms, which is abbreviated kg. Both of these letters are also lowercase. So go back up top and next to mass, kilograms, which is kg. This is an old definition. You should already know. Mass is simply a measure of how much matter something contains, or how much matter it is made of. Okay, but I do want to go into a misnomer. Okay, a misnomer is a common misunderstanding. Okay, it's a mistake that is made a lot. A lot of people think that there is no difference between weight and mass. There is a major difference between them, and you will have to know this. The difference between mass and weight is this. Mass, as we already said, is how much matter something contains. Weight is the force that is applied to that mass by whatever celestial body you happen to be close to. Now, from the last unit, you know that celestial body means moon, planet, or star. Okay, there are other celestial bodies that we're not going to mess with, comets, the asteroids. Those are technically celestial bodies as well. But for this conversation, the closest celestial body right now is the Earth. So your weight is how hard the Earth pulls on your mass. So let's go for some convenient math here. We're going to say that you have a mass, sorry, not a mass, that you weigh 120 pounds on Earth. That may be high, that may be low. Just roll with it. It gives us easy numbers, makes the math simple. If you were to go to the moon, your weight of 120 pounds would be about 1/6 of what it is on Earth. So instead of weighing 120 pounds, you would weigh 20 pounds on the moon. On the opposite end of that, if you go to Jupiter, you're going to weigh 10 times what you do on Earth. So instead of 120 pounds, you'll be 1,200 pounds on Jupiter. Because the moon is very small, Jupiter is very large, they have much different gravitational pulls. So the moon has a weaker gravity, Jupiter has a stronger gravity, so you weigh less on the moon and more on Jupiter. But in all three locations, your mass would be the same. Your mass doesn't really change. Okay, the force of gravity, your weight can change just depending on where you are on Earth. You weigh more in Death Valley in Nevada than you do at the top of Mount Everest. Not a lot more, but a little more. And that's because of things we're going to get into in a future unit. Okay, but that force of gravity is determining your weight. Your mass is relatively constant. There are only two things you can do to change your mass. That is, take in nutrients, or eat or drink, or expel waste. Going to the bathroom, sweating, that's going to be excreting waste. That's going to reduce your mass. So taking nutrients in increases your mass. Excreting waste reduces your mass. And that's why when you're a teenager, you eat like a horse, because you're growing. And you have to take on more mass in order to keep up with your body trying to grow. So you're hungry all the time. Now, English unit of mass is the slug, S-L-U-G. You're going to want to know that at some point. For weight, I want to mention this. Weight is measured in pounds in English. In the SI system, weight is considered an aggregate unit. It's made up of a bunch of these other things. And we measure it in newtons. Again, we have a whole unit dedicated to force later, but we'll get to that eventually. Time, this one is kind of a footnote. We measure time in seconds. Seconds is generally abbreviated with a lowercase s, unless you have bad handwriting, in which case I told you to use SEC instead, so I can tell that that is an S and not a 5. So SEC, S, or seconds. One thing you do need to know, that the abbreviation for hour in this class is going to be HR, both lowercase. So if something has HR, if you have a number that has HR at the end of it, that is a time. It's hours. Charge is measured in coulombs, which is abbreviated with a capital C, not a lowercase c. And temperature is our next spot that we're going to sit and camp out at for a while. The units for temperature are degrees, and there are 4 temperature scales that we're going to talk about in a moment. We'll do more with those when we do our temperature conversions video. Okay, temperature simply measures how much thermal energy something has. Again, we'll do more with energy in another later unit. But thermal energy is a type of energy. It's vibration energy. The more something vibrates, the hotter it is. Okay, or the more thermal energy it has. So, temperature is just how we measure that thermal energy. There are 4 temperature scales that we're going to be talking about in this class. There are probably other temperature scales beyond these 4. If you look, I am certain you could find some. These are the only 4 that we're going to deal with. Okay, the first 2 are the first and third in this list. F is Fahrenheit, C is Celsius. Okay, Celsius is also called centigrade. Okay, Fahrenheit and centigrade are the 2 most common scales. Most of the world uses Celsius. By the way, I'm going to use Celsius and centigrade interchangeably. Centigrade is easier for me to say than Celsius is. It's got fewer S's in it, so I'm less likely to mess it up. So I'm usually going to say centigrade, but if I say centigrade or Celsius, know that they are the same thing. Fahrenheit is used primarily in the United States. So that one, again, it's part of the Old English system versus the metric system. Now, they are not the only 2 temperature scales. There are 2 other temperature scales here, Kelvin and Rankine. These are used primarily by physicists, and again, we'll talk more about these later. The standard unit, so far as SI is concerned, is not centigrade, but rather Kelvin. So the standard unit for temperature is degrees Kelvin. Kelvin is spelled Kelvin. And that brings us to our last point, CGS versus MKS. These are simply 2 common sets of units. Okay, and they primarily deal with length, mass, and time. So the first letter is the letter for the length unit, the second is the mass unit, and the third is the time unit. So in CGS, we have C, which is length, that's centimeters, G, which is our mass, which is grams, and S, which is seconds for our time unit. And if you didn't write those down, you need to do that. Centimeters, grams, seconds. MKS, same order, length, mass, time, is going to be meters, kilograms, and seconds. Same basic idea. Okay? But there is a distinct difference between these two. CGS is smaller. A centimeter is less than a meter. A gram is less than a kilogram. Seconds is the same in both because getting anything less than seconds is really, really, really tedious. We use CGS when we're dealing with small amounts. Okay, chemists and biologists, which you need to add to this up here. CGS is primarily used by chemistry and biology. Okay, MKS is used much more often by physicists and engineers. Okay, architects also are going to tend to work here, but they can sometimes end up working on this side depending on what they're building. Carpenters are technically architects and engineers, but they tend to veer more on this side than this side. And that is going to wrap up this video. It's a little longer than I wanted it to be, but we're going to wrap it there. Have a wonderful time, whatever time it happens to be for you, and I will see you in the next video.